Hi everyone, welcome to the programming platform. My name is Arjit Nath, and in this video, I'll be going through the abstract factory design pattern. Before starting, I would suggest everyone to go through my video on factory design pattern for detailed understanding, as I would be continuing on the same example. I have provided a quick recap of factory design pattern so that everyone is on the same page. Let's get started. For our main topics today, at first we'll understand what is abstract factory design pattern. Then we'll have a quick recap on the factory design pattern that we have seen in the last video. Then we'll go back to the pizza store example where we'll incorporate abstract factory design pattern. And then we'll see what are the advantages of abstract factory design pattern. Abstract factory is a creational design pattern which provides an interface to create families of related or dependent objects without specifying their concrete classes. Now, what does that mean? It means that when you already have a factory pattern in place and you have a lot of related components in your business flow, you should use abstraction on those families of components rather than directly initializing the concrete class. Both the factory and the abstract factory design pattern follows the object-oriented principle called dependency inversion principle. Dependency inversion principle asks us to depend on abstraction rather than on concrete classes. This means in a business flow, the high-level components should not depend on the low-level components. Rather, both should depend on abstraction. Let's take a quick recap of the pizza store that we created for the factory design pattern. With the success of the London store, we decided to open two more stores, one in Paris and the other one in Lisbon. Now, what we decided was that every location will have their own style of making pizza that suits their customer. Thus, rather than keeping the pizza store and the pizza creation logic in two separate entities, we merged both into one abstract class called the pizza store. So at the end, we had one pizza store abstract class where we had the implementation of the order and an abstract method for creating the pizza object, which will be implemented by the individual pizza stores. Now we have three pizza store classes, the London pizza store, the Lisbon pizza store, and the Paris pizza store. So in the London pizza store, we are extending the pizza store abstract class and we are giving an implementation to the create pizza method. Now, depending upon the type of the pizza that comes in, we are creating an object of the same pizza, London style. Whereas for Lisbon, we are creating the pizza Lisbon style, whereas in Paris, we are doing it Paris style. So we have four classes over here: London pepperoni pizza, London sausage pizza, London cheese pizza, and London veg pizza. All of these pizza classes, say the London pepperoni pizza, is extending the pizza abstract class. And it is providing the name of the pizza that we are trying to prepare, and it is overriding the prepare method and just printing what is the name of the pizza that we are preparing. We can give any kind of business logic that we want over here. The pizza abstract class provides the name of the pizza and the default implementation of all the prepare, bake, cut, and box method. This is how we had implemented the factory design pattern. Now consider that the individual pizza stores are considering granularly selecting the ingredients for the pizza to better serve their customers. The London pizza store wants to go with thin crust with mozzarella cheese, whereas the Paris pizza store and the Lisbon pizza store wants to go with few of their own selected ingredients to serve their customer. If you think closely, the ingredients used to create the pizza comes under the family of dependent elements required to create the pizza and thus to the pizza store on a high level. Thus, by definition of abstract factory pattern, we should try to initialize all the ingredients without specifying their concrete class. Consider that the pizza store wants to granularize the ingredients into types of cheese, dough, pepperoni, and sausage that will be used to prepare the pizza. If you want, you can add more items to further define the pizza creation process. For each type of ingredient, we have created an abstract class. Say for cheese, we have created a cheese abstract class. For dough, we have created a dough abstract class. And similarly for pepperoni and sausage, we have created their own abstract classes. The abstract class will have the type of cheese that we want as a string, and we'll get that data from a getter method. So the cheese will have a cheese type, whereas the dough will have a dough type. pepperoni will have a pepperoni type, and sausage will have a sausage type. And all these abstract classes will have their individual getter methods. Now, using the abstract classes, we can create individual class for the type of the ingredients. Like for cheese, we have created two classes, one for cheddar cheese and the other one for mozzarella cheese. So if you see, the class mozzarella cheese is extending the cheese abstract class, and it is providing the name of the type of cheese, that is mozzarella cheese, whereas cheddar cheese class is extending the cheese abstract class and providing the cheese type in the constructor. Similarly, for dough, we implemented two different types of dough, Paris special dough and thin crust dough. The thin crust dough is again using the constructor to give the dough type. The Paris special dough is giving the dough type using the constructor again. And so on. For pepperoni and sausage, we have used cube pepperoni, turkey pepperoni, and for sausage, chicken sausage and Italian sausage with the same implementation. Thus, using this technique, we are providing an abstraction to all the related ingredients for the pizza creation process. Now think about it. We have all the ingredients. How will we let the store know that they can use the ingredients? We have to let them know during the pizza creation process, that is through the create pizza method of the individual stores, that the ingredients are available at their disposal. So as I mentioned, we have to go to the London pizza store, and inside this create pizza method, we have to let them know that when they are creating a London pepperoni pizza, they have all the ingredients at their disposal. Or if they are creating the London cheese pizza, they have all the ingredients. Similarly for Lisbon, in the Lisbon pizza store, we have to let them know during the pizza creation process that they have all the ingredients at their disposal when they're trying to create the Lisbon pepperoni or the Lisbon veg pizza. Similarly for Paris as well. Now, one thing we can do is we can directly create the object of the ingredients that are required for, say, Lisbon pizza store. We can directly create the objects of the ingredients over here inside the create pizza method and pass it as a parameter to the Lisbon pepperoni pizza or the Lisbon sausage pizza. But if we follow that procedure, we'll come back to square one, wherein we are again falling into the same trap of doing concrete class initialization, which is completely against the norm of factory and abstract factory design pattern. Thus, we have to use a factory for all the ingredients as well. For that exact reason, we have created an interface called the Pizza Ingredient Factory interface and created a method for all the ingredients that we want to add. Like for dough, we have created a create dough method, which will return a dough type. For sausage, we have created a create sausage method that will return a sausage type. Similarly for pepperoni and cheese. This pizza ingredient factory will be implemented by the individual stores and will return the type of ingredients that they want to use. Like in the London package, we'll create a class called the London Pizza Ingredient Factory, which will implement the pizza ingredient factory and provide implementation for all these methods: the create sausage, create dough, create cheese, and the create pepperoni. For the create sausage method, it will return a new chicken sausage. For a create dough, it will return the thin crust dough. Similarly for cheese, it will return the mozzarella cheese, and for pepperoni, it will return the turkey pepperoni. Similarly for Paris, we will have a Paris Pizza Ingredient Factory, which will implement the Pizza Ingredient Factory and provide implementation for all those methods. For create sausage, it will return the Italian sausage. For dough, it will return the Paris special dough. Similarly for cheese and pepperoni, it will have its own implementation. Same goes for Lisbon. It will have a Lisbon Pizza Ingredient Factory, which will again provide the implementation for all the ingredients that are required for creating a Lisbon style pizza. What we are trying to achieve here is that all the pizza stores will have a factory of ingredients to create their own style of pizza. Thus, you can understand that in a very loose coupled way, we are giving the respective stores the freedom to create their own pizza with the ingredients of their choice. Now, from the respective pizza store, say the Lisbon pizza store, we are creating an instance of the pizza ingredient factory, and during the constructor initialization, we are creating a Lisbon pizza ingredient factory because it is for the Lisbon pizza store. So the Lisbon pizza ingredient factory will give us access to all the ingredients that are required to create a pizza for the Lisbon pizza store. Now, in the create pizza method, when we are trying to create a pizza, we will send the pizza ingredient factory instance to the different pizza creation classes. Now, since we are sending the ingredient factory into the individual pizza creation classes, say in the Lisbon pepperoni pizza, we only want to use the cheese and pepperoni. We don't want to use a sausage or any of the veg components. So, when we are initializing the Lisbon Pizza ingredient factory inside the constructor, we are free to choose whatever we want to do with the ingredient inside the prepare method. Similarly, in Lisbon Pizza cheese pizza class, we are only using cheese along with the dough. So, similarly, we are free to use whatever ingredients we want to use while preparing the pizza. And the same goes for the London pizzas as well as the Paris pizzas. Say in the London veg pizza, we only want to use dough and cheese and nothing else. Similarly, for say Paris sausage pizza, we want to use cheese and sausage. So whatever ingredients we want to use for the specific location, we are using the location's ingredient factory to get the ingredient. Let me again recap the flow. From the main method, we are creating a pizza store and initializing the London pizza store in this reference. Then with the London pizza store reference, we are calling the order method and passing the cheese pizza type. So basically, from the London pizza store, we want to order a cheese pizza. So let's go to the London pizza store. In the London pizza store, once it gets a cheese pizza, it will create an object of the London cheese pizza. Before creating the object, it will try to initialize the London pizza ingredient factory and pass that pizza ingredient factory as a part of the cheese pizza creation process. Now, inside the London cheese pizza class, what we are doing is we are initializing the London pizza ingredient factory, and in the prepare method, we are preparing the pizza with the ingredients that we require. Let's execute the program from the main method to see how it goes. So if you see over here, when we are trying to order a cheese pizza from the London pizza store, it is saying that preparing London cheese pizza. Dough type is thin crust dough. Cheese type is mozzarella cheese. Why are these two showing? Because for the London pizza, if you go to the London pizza store and in the London cheese pizza, you will see we are trying to create the dough as thin crust dough. Where is that? In the London pizza ingredient factory, if you see, the dough is a thin crust dough, whereas the cheese type is mozzarella cheese. Then it is trying to bake the London pizza, cut the London cheese pizza, and box it. Similarly, for Paris Pizza Store, we are ordering a pepperoni pizza. Now, while preparing the pepperoni pizza, it is using Paris special dough and cheddar cheese in the preparation process. If I go to the Paris Pizza ingredient factory, you will see that the cheese is a cheddar cheese, whereas the dough is a Paris special dough. The rest of the process remains same. Also, the pepperoni type is cube pepperoni. So if you see over here, the pepperoni type is cube pepperoni in the ingredient factory. For the Lisbon pizza store, we ordered a sausage pizza. If I see the main method, we are ordering a sausage pizza over here. The dough type is thin crust dough, cheese is mozzarella, whereas the sausage type is Italian. Let's go to the Lisbon pizza ingredient factory and see whether the data is correct or not. The dough type is thin crust dough, the cheese is mozzarella cheese, whereas the sausage type is Italian sausage. The rest of the process is same. This is how abstract factory design pattern works. If you look closely, all the methods in the abstract factory design look similar to factory design pattern, wherein each method is declared as an abstract and subclasses override it to create an object. But abstract factory is a special case of factory design pattern, which is used when we have related or dependent objects of the factory creation process. Also note that since abstract factory is a special case of factory design pattern, it also follows the same principle as factory, like the single responsibility principle and the open-close principle. Abstract factory allows you to loosely couple all the related or dependent classes, which otherwise would have become extremely complicated and hard to maintain and understand. I hope you guys have got a clear understanding of the abstract factory design pattern. Please like and subscribe my channel for more videos on design pattern, software architecture, and data structures. I will add a GitHub link of the code in the description section below for easy reference. Thank you.